So this is what you see, and then there's kind of two different things you can type, and there are math lines. That's what I call math lines. Whenever you see the box there, that's a math line. And then you can do a text line. So math line, so for instance, 5 times 9.6. You can put in all kinds of mathematical statements, computations. Here's 5 times 9.6, and then it tells you it's 48. As soon as you change it, it updates, right? It updates the answer to the current expression that you've put in there. Okay, and then the other thing you can do is text lines. So if you do Control T, so then you can just type. So this text line is totally optional, helpful for bringing this later in your work. Okay, so especially when you have lots and lots of math lines, it's really helpful to put text lines in there for your reference, right? Like as markers of what you're doing, where things are. Make sense? Okay, so then to go back and get another math line, you do Control Return. Control Return is always how you get a new math line. Okay, and so to do, so like say 8 times 6 plus, so pi, just type pi, and it turns it into a pi. Now suppose I didn't really, this isn't what I meant. What I meant was 8 times the quantity 6 plus pi. So I think I could highlight, let's see, it'll let me, no, I don't want to do that. So what I can do is you could do Shift 9. As soon as you put the left parenthesis, it just gives you both parentheses. You never have to type a right parenthesis. So what did I have? 6 plus pi. So now that's got what I want. And then you can like highlight certain things, copy and paste. Like I can highlight. So it's like, oh no, what I meant was minus. E. E stands for its value, E, 2.817, 2.71828, that whole thing. So that's what E is. There's built-in powers for squared and cubed. If you just do Shift 2, it automatically does square. Shift 3. So now I could just, if I came up here to the 2, I could do Shift 3. Shift 3 gives a power 3. Any other power? So say I want the cube root of the 6 plus pi. You're going to do Shift 6 for a caret. And then you can do, so I want the cube root, so that's 1/3. Okay, and then suppose if I want to just divide that first thing, I could like highlight that and then hit /, and then I can create a fraction for just that first term. So say, and then square root is Option V on a Mac, or Control Shift S, I think, on PC. Try that. Control Shift S. Square root. Does it work? No? Okay. Control Shift R, maybe?
Yes.
Control Shift R on a PC gets you the square root. Option V is for Mac. So now here I want the square root of 30, whatever, plus 2.1 cubed. So I can do Shift 3. So whenever you have a valid expression, as you're changing it, it's always updating the answer. See that? And then you could copy and paste. So I can copy. Then you have the capabilities of a word processor too. So I could highlight the whole thing, copy, start a new math line, Control Return, and paste. And then it's right there. And then I could vary, alter that one. Everyone with me so far? Are we good? Wrong time, wrong class, wrong day. right? So it's like, oh no, I didn't want that. No. Just wanted minus e. Wow, I ended up with a number really close to 0. That's pretty amazing. That wasn't totally unintentional. I'm a nerd. Okay, whatever. Okay, so I noticed these things. All right, so let's see. What should we do? Graphing. So let's do a little bit of graphing. No, while we're here, let's do this. Let's do this thing. So here's a geometric figure. And so what I want to do is using only the values in the diagram, 4, 5, and 9, and 2 is okay, and pi, we should write one expression that gives the area of the region inside of the trapezoid, but outside of the circle, and that consists of four places. So inside, all this area inside the trapezoid, outside the circle. You see that? So this, the total area of those 4 chunks. Okay, and I want you to make one expression on one math line. Make one expression that when you do it correctly, then it tells you what the value of the area is in one expression. You can only use 4, 5, 9, 2, and pi. Here's your area of a trapezoid, area of a circle. All right, work on that. See if you can get it. So again, you're using one math line on GC. One math line on GC that's going to compute that area. Go. So you can think about it on your own. You can consult with each other. No, they're lengths, right? So, yeah, those are all lengths on the diagram. I'll show you. So 4, say, so there's a tangency, point of tangency right there. So 4 is the distance from there to there. It's 4. And then 9 is the distance from there to there. And then this is 9, and so 9 to here. This is 9 from there to there, 9 from there to there. 5, this is 5 from here to here, is 5, etc. Does it make sense? Okay, so a little problem solving, a little ingenuity, but one expression that when you finish it and get it correct, GC will tell you the area, this area here. All of the cross-hatched area. Okay, so either making progress or you're getting help. Either making progress thinking and working, or if you're stuck, then get some help. So shift 8, the asterisk, is multiplication. I didn't tell you that. So that works for, or you can use parentheses, whatever you want. So parentheses or shift 8 does multiplication. Or you can just add 2 together. That's perfectly legit, yeah. That's fine. How they do in the trapezoid? Is that right?
Yes.
Did it? Oh, right. You got me. You got me. How does it do? Come on. What the? There we go. Okay, so the trapezoid, area of the trapezoid minus area of the circle, and then the. So this is just a practice with parentheses and exponents and pi, and show that you can type in expressions. And so there's a nice thing about this is that you see the expression and the answer. And a really awesome thing to work with your students on is identifying meanings of parts of expressions. Yeah, question. No, you weren't allowed to use one. Here we go. All right, is that better? Okay, so back to my point. A really good exercise to do with your students is, you have the expression here. So identifying parts of an expression and knowing the meaning in the situation. So for instance, what's the meaning of that part of this expression? So what's that meaning? So this is a great thing about GC because it gives you the final answer, but then it holds everything you put in at the same time. So ask your students, what's the meaning of that? What does the value of that thing mean in this scenario? Okay, and then similarly, what's the 4 times 2? And those are pretty easy questions, but these are really, really good questions for students when you have a large expression like that. So along those same lines, let's do this one. Any questions on this geometry problem? So more practice on the same. I've got this one here. So the dimensions of a dollar bill are 15.5956 centimeters by blah, blah, blah centimeters by blah, blah, blah centimeters. That's the thickness, 0.010922. Find the total amount of money in a block of $50 bills measuring 6 foot by 3.5 feet by 2 feet. Think that's a lot of money? I'll take it.
Yeah.
Sounds pretty good to me. This is actually from Breaking Bad. Did you see Breaking Bad? Anyone watch Breaking Bad?
I don't remember.
So the wife was stockpiling the money in a storage unit. So there's a scene where she's got this pile about this size, 6 by 3.5 by 2, and it's all different things, but we just assumed it was $50 bills, and so how much money had they amassed in the storage unit, and so that's what you can figure out. So here's some conversions. 3.28 feet in 1 meter, 2.54 centimeters in an inch, 5,280 feet in a mile, and same thing, one math line in GC, so that when it's all said and done, the answer is telling you this amount of money. How much money is in that block of cash? And then also there's 100 centimeters in a meter, if you didn't know that. Okay, see if you can do it. In one math line, can you come up? And you guys could have different expressions that all get to the same answer, right? So this one, there's kind of more variation in the approach that's possible. So you could all end up with different answers.
Are we assuming you're stacked up like quarterly, or is it the volume?
Yeah, assume that there's no airspace. Assume there's no airspace in this.
So
it's all $50 bills. The whole block is $50 bills with no airspace. That's what we'll assume. You know, maybe we do 95% of your answer at the end to account for error. Meter, so you got meters, and then centimeters cubed. And then, yeah, good job. Okay, so what I'll do is I'm going to put up my solution, which is different than the two that have been done so far, and we'll do what I was talking about. Okay. So like you could start with this. What does that number represent? Right? You ask your students. What does that number represent? 6 divided by 3.28. What will that give you? And then say this expression. So there's an expression. Nope, just the top, just the numerator. What does that give you? What is that?
Like when you divide them,
Yeah.
you get meters, so then you multiply that whole expression
Okay.
by 100.
No, I just want to know what this expression means that I've highlighted in blue.
Oh,
So how can you describe exactly what that?
you're converting your feet into
But that will be a value, right? This is a value. What does that value represent in this problem, Robbie? Okay, so you're still talking about the computation, and I'm asking you to interpret the value, right? Right. That'll be the volume of the block in meters cubed, right? So what you were saying was correct, but you were kind of answering a different question. So this is, each one is the dimension of the block in meters, and then the whole thing will be the volume of the block in meters cubed. And then what is, say, what's this right here? What's that number mean? Width of? Right. Yeah, or the smaller dimension of a bill in meters. That's right. And then the whole thing on the bottom would be the volume of a bill in meters cubed. Right? Super small. But like Lydia and Melissa had totally different expressions from mine. So there's lots of ways to skin this, do this. Okay, any questions on basic computations in GC? So we'll go on to graphing next. And if you want to, this is all recorded on the video. If you want to come back and look at this, keep working on it later, you're welcome to do that. So it's all there for your use. So let's go back to and say, so in order to graph in GC, to prompt GC to graph is the lowercase x, y, and z. So lowercase x is our conventional use of that, is all values on the x-axis. Lowercase y, values on the y-axis. Lowercase z, the z-axis, if you're in R3. If you guys have had Calc 3 yet. Calc 3 is about x, y, and z, three-dimensional space. Okay, so if I type in y equals 2, what does that represent? What does that represent to GC? Remember I told you lowercase y is prompting GC to display a graph. So what does it display? Straight line. All lines are straight, so you need to say all lines are straight. Horizontal line, right? Horizontal line. Not the first to have done that. In fact, every time I ask that question, I get that answer straight away. Okay, so horizontal line at 2, but really, it didn't really take that statement and say, oh, you want me to graph a line? What did we talked about last time? Really, what is it graphing? No, there's no function here. No function here. What did you say? Points, right? So when it sees that, whenever it graphs something, it is graphing a point or a set of points, always, no matter what it is. So this is the set of points such that what? X can be anything. For every x, y has a y coordinate of 2, and that makes the horizontal line, right? So you may have your graph on the side or below. It doesn't matter. You can change that if you go to File, if you go to Document Settings. You can show, here I'm showing graph to the right. You can show it below. That's the default is usually below. Change the font. Change in terms of how big the text or how big the math lines, the text in the math lines. You can choose that there. File, Document Settings. Okay, so when you get the graph, you notice that hands pop up when you on the axis, so you can hold on and drag, move your origin or your axes around. Okay, you can zoom in or out down here, lower left corner. You have the zoom buttons. So zooming out is the first one, the little mountain. Zooming in is the bigger mountain there. Okay, so if I want to graph my favorite parabola, what should I type in? My favorite baseline parabola? X squared, right? So y equals x squared. Let's make that red. And what is that doing then? Does it go into its memory banks and say, oh, you want the parabola y equals x squared? Graphs the parabola? No, what does it do?
Graphs every y point for corresponding square of the x. There's a better way of saying that.
Yes, the general gist of your answer is correct. It's going to graph a bunch of points, right? Each of those points, the x and y coordinates are in this relationship, right? Y is whatever x is squared. So it's going to graph a bunch of points. Okay, then you can click on the graph and you get crosshairs, and the crosshairs you can it will isolate particular points, right? So here now the crosshairs on the point -1.9 blah blah blah, 3.8 blah blah blah, and then you can drag the crosshairs and it will adjust, the coordinates will adjust, and then if you turn it up here for intersections, it'll lock on. Also for like maxes and mins and intercepts, so it should lock on there at the origin. And it does a little knock when it locks on there. I don't think it might, let's see. To get it off a graph, you gotta take the crosshairs off of the viewing window, and then you can, so I'll start on the other one here. It does not lock on the y-intercept. It does not lock at 0. You can get it on 0, but it doesn't lock. Okay, so let's put in another equation here. I got another equation down here. Where is it? There we go. So new math line, control return, and we'll go y equals 4x to the 5th. Plus 8x cubed. Remember, square and cube are just shift 3 and shift 2. So the best colors for like curves and lines are purple, red, blue, and black. These other ones don't show up often very well, the green, blue, yellow, and gray. So don't recommend using those. Change it if it comes up as one you don't want. So it's a little messy here. Let's go off and turn off our parabola. So come up here to the red one. If you click on the red, you can select the X, and that'll keep your relationship, your equation, but just not graph anything. You can X that out. So now we want to get a better view of this. We're not really seeing all the features of this quintic polynomial to the fifth. So we can zoom out. What happens when we zoom out? Well, that's not too much. It's just that all the action here is in the very middle. It's all crunched together in the middle, right? So in terms of y, it's good, but my x is no good. So what I'd really like to do is zoom in or out on the x-axis. I want to zoom in on the x-axis. Okay, so you can zoom on separate axes. If you go to Option or Command on Mac, and I think it's Control and Shift on PC. So which one zooms on the x-axis? Option. What about for PC? Is it Shift or Control?
Oh.
So when you hold down those, look at the box, and you'll see the little arrows come up, either horizontal or vertical arrows.
Yeah, control is X, shift is Y.
Okay, so if we want X, it's which one? Control. All right, and so for Mac, it's Option. So we want to zoom in on the X. Is that what we decided? So there's a nice view of this polynomial. So notice my scale is much different on the X and Y. On the Y-axis, I'm in the tens. On the X-axis, I'm in the 0.1s, right? Every tick was a 0.1. Question, yeah?
I did the thing where I made a box and then it will zoom in on the box.
Yep.
How would you get out?
So we just zoom out. Or you could, okay, so anytime you could just start over, you can go to the graph menu at the top, and as reset graph. That will work. Or you can just start zooming out. Clicking on the zoom out button. But then, depending on how you made your box, when you zoom back out, you'll have, your axes will be weird, so you may have to readjust your axis. And you can, again, you can do that by holding down Option Command for you, it'd be Control or Shift. Everyone got a good view of this? Something try to get this view. Everyone get this view. Every tick mark is 10 on the y-axis. Every tick mark is 0.1 on the x-axis. So can you get to that particular zoom on both axes? So make it look just like that. See that? You just hold down Shift or Control and then click on these boxes, and it only stretches or zooms in on that particular axis. Okay, and so then you can do the crosshairs. Again, do the intercepts. So this should lock on the intercepts, x-intercepts at the intersections, the maxes, and the mins. So you got lots of places where it's going to lock here. Yeah, 1, 2, 3, 4, 5, 6, 7, 8 places where it should lock on the polynomial. 1, 2, 3, 4, 5, 6. Yeah, 8 places. Any questions? On the what? It should. It doesn't do the y-intercept? Yeah. Only x-intercepts, yep. That's what mine does too. So for some reason, I don't know why you're not getting the maximum in. You should. Okay, so that's just basics of graphing. right, again, you can move the axes, you can change the window by changing the size of just changing the size of your display window can, give you a different range that you're showing. We talked about zooming. Any questions on any of that stuff? Okay, so let's look at this. We're gonna go with this. So that was just, so this is going back to more like calculational stuff, not graphing stuff. This is the first part. This is the first 4 pages, pages 5 and 6. I mean, actually, 4, 5, and 6. Yeah, pages 4, 5, and 6 of this. 5 and 6 you'll get on Canvas. I only printed out the first 4 pages. Have work that you'll do, and now that so what I'll do is we'll flip flop. We'll do the critical précis for next Tuesday, and this thing will be for Thursday. Okay, but we only have 10 minutes, so we gotta kind of move here. So, I'm just gonna open up a new GC window. You just do Command N, maybe Control N on PC. Is that right?
Yep.
Okay, so this is about mortgage payments, and you see this formula here. The payment is what? R over, right in the middle, R over 12 times P times 1 over this denominator. And then we've got this table down below of these, okay? So we could just type this in. So in the first line, tell me what R is. It's a 0.06 divided by 12, right? Times, what's P? What's the principal? I don't have much light up here, so I'm going to ask you for your help. 250,000 times 1 over, times 1 over 1 minus parentheses 1 plus 0.06 divided by 12, or no, sorry, is it 0.06? 6 divided by 12, and then raised to the number of payments, how many is it? Negative 180. Raised to the power negative 180. And the monthly payment on the house is $2109.64. Okay, so then I could start a new line, and in the new line, I would put in the new values for the new rates and principal and number of payments, and get the payment. What do you think about that? Is that easy? Yeah, you can copy and paste and change the numbers, right? So this is one way to do this calculation. Now another way is we could actually use what we call parameters. So like X, Y, and Z, those are special characters in GC because they tell GC to graph. But any characters that aren't special, and there are other special characters too, lowercase e, pi, etc. But any characters that aren't special are just free parameters. So notice if I just type capital P, notice what it did. You see what it did there? Why does it equal 1? Yeah, it's what it's, so it's like this is, so it's telling you capital P is free for you to use, okay? If you don't tell me what it is, GC says it's going to be 1. That's the default, right? That's the default. So what do we want in the first line? What do we want P to be? P equals 250,000. So now it actually started a new line. So now P no longer has the value of 1. It's the value of 250,000. And what was R? 0.06. And what's our last one? Is it N? Let's use capital N because little n is for something else we'll get to later. Little n is a special character in GC, so we use capital N. It's not special. And what is on 180? Okay, we can do that. And then we can make a formula. And so we're, besides using characters as parameters, we can also use strings, meaning like a word. So to make a word into a single variable or parameter, you do this. You do backslash, which is upper left-hand corner. No, it is above return. This one. Sorry. This is truly backslash. Slants down to the right. Then you type your string in. So we want PMT, so capital PMT for payment. And then once you hit the backslash again, notice the backslashes go away, and now this group of letters together make a single parameter, like capital P, like R, like capital N. Does it make sense? So remember that. That's really helpful. Backslash, type your string of letters, then backslash, and then you get this. So we want payment to equal what? R divided by 12 times, so now we can make a formula out of those parameters. R divided by 12 times P times 1 over 1 minus, what is it? 1 plus R over 12 to the negative n power. Okay, and so then I can, so now we've assigned capital P to be this value, capital R to be this value, etc. And we've assigned payment to be whatever's computed, right, in this formula by R, P, and N. So how do I find out what the payment is for these three? What do I do? No, but I want to know what the payment is, right? So suppose we don't have this. Make that first thing go away. Now how do I know what the value of payment is? You're so close. How did we know? Like when I typed capital P, it just automatically told me what it was 1. So all I have to do is do what? If I want to know the value of something, you just type PMT, and it's not showing up. Why is that? That should work.
Did you have to do the backslash?
No, because it knows, like, right? So when I start, you don't need to. Yeah, so it knows that all you have to do is the backslash once, and then it knows. But I don't know why this isn't telling me what payment is. There's a mistake somewhere here. Oh yeah, I'd use capital R. You are right. R is special. Use capital R. Change the little r's to capital R and it should work. One more. There we go. Yeah, you're right. So little r is also something special. It's like radius and trig. So once we switch it out to capitals, then it should show the payment. So now, how can I do the next line in the table? Right, what's in the second line? What's P? 48,000? Tell me what it is. 480,000. 480,000. Okay. And then R is in the second line? What's R in the second line? 0.0625. And capital N. So watch. Now I've got the new values. This payment is still defined this way, and it just tells me what the answer is. See what happened? So I didn't have to change. Payment changed automatically according to how we define payment and the new values of RP and N. Yeah. You good? Did everyone get it? Yeah. Right. That's the little r. So did you have little r's there somewhere still? Yeah, that's okay. Did it work? Did the numbers work? Yeah, you got it. Yeah. Okay, so this is the difference between like putting the doing an expression. The first time we did an expression like this with all the numbers, right? And that was kind of a lot of work, and especially it'd be a lot of work if we did that row by row in the table. So this is a definite step of improvement here. Define payment as this formula, and all you have to do is then change the values of RP and N, and then payment automatically updates. So you could finish that table really, really quick and easy. We're at 115, is that right? Yeah. Okay, so is that page 2? Yes. So we made it through page 2. Oh, and so here in that box there, so we're talking about special characters. In that box on page 2, X, Y, Z are lowercase t, U and V, E, pi, I, and lowercase n. So these are the ones that are like not free parameters. Most of the capital letters are free to use, like we use P, R, and N here. Okay, but these particular ones in the box are ones that you don't want to use just to be variables in formulas like this. Okay, so we didn't get as far as I wanted to today. That's okay. The critical price C assignment will be due a week from today. We'll do a week instead of Thursday. And then in terms of what you'll have for this coming Thursday, I'll have to think about that and get that up this afternoon. Did you understand what a critical price C is? Did you read that part of it?
It's like almost like a summary, but like redone.
Yeah, it's like you're rewriting the article, but in a condensed version, in a much shorter version. So it's more than a summary, it's more than an abstract, but it's less than the article, right? But then you're just recreating the article. You're not injecting your reflections, your opinions. There's nothing. It's just a recreation, a reproduction of the article in short form. And then there's some follow-up questions also after you do that.